morning, children. In today's class, we are going to learn about Poisson distribution. It is one of the discrete distributions. Poisson. This was invented by Simon Poisson, and by his name, this distribution is termed as Poisson distribution. Poisson distribution is based on rare events. What do you mean by the word rare? Something that does not happen frequently. For example, you can immediately say accidents on a road. There may be 1,000 vehicles passing by the road in a particular unit of time, but one or two or none may have an accident. Similarly, a company may produce lots of production in thousands, crores or lakhs, I can say. In all these productions, 1 or 2 or maybe 10 out of 1 lakh or maybe 20 out of 3 lakhs may be defective items. So number of defective items in a lot we call as Poisson distribution. Like this, you can think of certain events which are very, very rare will come under Poisson distribution. In today's class, let us do some problems reading it. In the question, whenever we are given, try to identify what is average. Average or mean we call as lambda. As I read the problem, try to check for these words. Average or mean is mentioned. That you term as lambda. Some problems, they don't give lambda as such. Instead, they give number of trials and probability. For example, 1,000 items are produced in which 1 is a defective. So, n is 1,000, p is 1 by 1,000. Multiplying n into p, that gives me lambda. So, having learnt binomial, we will try to link binomial with Poisson, where n is very large and p is very, very small. So, we understand Poisson as a limiting form of binomial. Let us start with the exercise problems. Exercise 7.2, question number 1. Define Poisson distribution. A random variable x follows Poisson distribution with parameter lambda if its probability mass function is given by p of x is equal to x is equal to e power minus lambda, lambda power x by x factorial. What is the difference between binomial and Poisson? Binomial, we say 0, 1, 2, 3 up to n, where n is finite. But in practical life, there may not be finite alone. There may be infinite trials also. In that case, we find out Poisson distribution. Also, in practical life situations, there are incidents which are rare. So, binomial we said only 2 possible outcomes, success, failure. But in Poisson, we say the events are rare. For example, accidents on a road in a particular time, printing mistakes in a page of a book. So like this, in production, defective items alone. So these are examples for Poisson. In that, I should know the parameter lambda and x ranges from 0, 1, 2 and so on. Here also, x takes only non-negative values. And lambda is the parameter which is always positive. As usual, x represents number of successes. So, in Poisson distribution problems, number of defectives, number of mistakes, number of accidents, we call as x. So that we mean e power minus lambda, lambda power x by x factorial gives us the probability. Examples of Poisson distribution, as already discussed, at least be familiar with 2 examples. Number of printing mistakes per page in a textbook. Number of road accidents occurring at a particular interval of time per day. When binomial becomes Poisson. Binomial, we already have the parameters n and p. When does it become Poisson? If n is finite, we are in binomial. If n tends to infinity, we are in Poisson. Also, P, the probability. I said the examples are printing mistakes or accidents, or generally I can call they are rare events. Rare events tell me the probability is almost zero. Sometimes no accidents may be there, or out of 1,000 vehicles crossing, any one or two would come across with an accident. So probability tends to zero where n tends to infinity if I multiply. What would be my answer? Say 10,000 vehicles are passing and 2 out of that meet with an accident. If I multiply, my answer is 2, which is neither very small nor very big. I can say it is a finite quantity. This is the condition for binomial to become Poisson. N tends to infinity, P tends to 0, NP, the product, is a finite quantity. That finite quantity only we call lambda. So in exercise problems, n and p are given, multiply to get lambda. So binomial, only two outcomes, whereas Poisson, rare events we say when n tends to infinity and p tends to 0, NP, the product which is termed as lambda, is a finite quantity. Question number 5, exercise 7.2, properties of Poisson distribution. Easy to remember, mean is lambda, variance is lambda, both are equal. In binomial, variance is less than mean. In Poisson, mean and variance are equal. That is the most important property to remember. So in Poisson, parameter is lambda, mean is lambda, variance is lambda, and both are equal. To find mean and variance of Poisson distribution, question number 4, exercise 7.2. What is a Poisson distribution? P of x equal to x is e power minus lambda, lambda power x by x factorial. What is mean actually? We write e of x, which is sigma x into p of x. That is sigma x is equal to 0 to n. Here n will come. It's a Poisson distribution, so infinity will come. X is equal to 0 to infinity. P of x is e power minus lambda, lambda power x by x factorial. See, 5 factorial I can write 1, 2, 3, 4, 5, which is 4 factorial into 5. In the same pattern, x factorial can be written as x minus 1 factorial into x. 5 is 4 into 5. Same way, x is x minus 1 factorial into x. Writing it here, x is equal to 0 to infinity, x into e power minus lambda, lambda power x by x into x minus 1 factorial. We are writing from here. X and x will get cancelled. I am left with this lambda is not affected by sigma. Bring it out. E power minus lambda is out. Also, denominator x minus 1 tells me lambda power also should be the same. So, I can write it minus 1 plus 1. When the power x, add 1, subtract 1. This lambda power x minus 1 I need for this factorial. Bring lambda power 1 out. So, it comes out like this. Sigma x is equal to 0 to infinity. I have taken e power minus lambda. I have taken lambda power 1. What is remaining? Lambda power x minus 1 divided by x minus 1 factorial. This full idea becomes e power lambda. It's a formula. sigma lambda power x minus 1 by x minus 1 factorial gives rise to lambda. And when x minus 1 is coming, remember to put the sigma value from 1 onwards. Here also start from 1, because whenever x is in the denominator, it shouldn't become 0. So start from 1. Now these two gets cancelled. E power lambda, e power minus lambda gets cancelled. I am left with lambda. So mean of Poisson distribution is a simple idea which becomes lambda. E of x square equals sigma x square p of x. That is sigma x square. What is p of x? E power minus lambda, lambda power x by x factorial. X ranges from 0 to infinity. The next step, sigma. Since x square is coming, remember what we did in binomial? Subtract x, add x into e power minus lambda, lambda power x by x factorial ranging from 0 to infinity. Combine these two. So sigma x is equal to 0 to infinity, x into x minus 1, e power minus lambda, lambda power x by x factorial plus sigma x is equal to 0 to infinity, x into e power minus lambda, lambda power x by x factorial. The first two terms into this, the third term into this. This full idea as we derived from the previous step is lambda. I need to simplify this. Sigma x is equal to 0 to infinity, x minus 1, e power minus lambda, lambda power x by. Remember, how did we write x factorial? X factorial can be written as x minus 1 factorial into x. I can write one more step, x minus 2 factorial into x minus 1 into x. So this is x minus 2 factorial into x minus 1 into x. So I can cancel these two. The moment I write x minus 2 factorial, change x from 2 to infinity. Because x minus 2 is coming, in lambda power also put minus 2 plus 2. So which will come out? E power minus lambda will come out. I want only lambda power x minus 2, denominator x minus 2 factorial. So lambda power 2 will come out. Sigma 2 to infinity plus lambda. This full term, as in the previous idea, will become e power lambda plus this lambda will come as it is. E power lambda, e power minus lambda will get cancelled because they are reciprocal to each other. My answer is lambda square plus lambda. Now I need to find out variance. What is the formula? E of x square minus e of x the whole square. What is e of x square? Lambda square plus lambda. What is e of x from here? Lambda. Square of it is lambda square. Cancel these two. Again I get only lambda. So in Poisson distribution, it is easy to derive and remember. Mean is lambda. Variance is also lambda. Being a 5-mark question, let us go through the steps once again. Poisson distribution, the formula is e power minus lambda, lambda power x by x factorial. To find the mean, it is e of x, sigma x into p of x. X into p of x we have copied. How to write this x factorial? Previous number factorial, that is x minus 1 factorial into x. X and x cancels. Since x minus 1 is coming, in the lambda power also try to bring x minus 1. So put minus 1 plus 1. I need only this part. X and x cancels. So e power minus lambda will come out. Lambda power 1 also will come out. The remaining reduces to e power lambda. So e power lambda and e power minus lambda cancels and my answer is only lambda. Proceeding in the same pattern, e of x square. Sigma x square p of x. Again p of x we copy from here. Whenever x square is coming, subtract and add x. Combine the first two terms alone and the third term will come separately. So first two terms into this, x into this, y, x into this we already derived as lambda. So x into this term I can simply put lambda. The first part, x square minus x is common, it becomes x into x minus 1. So denominator let us rearrange. X factorial can be written as, if I simplify, x factorial. See for example 5 factorial. 1, 2, 3, 4, 5. I can write it is 4 factorial into 5, or 4 factorial again can be written as 3 factorial into 4 into 5. The same idea, x factorial can be written as 1, 2, 3 up to x minus 2, x minus 1, x. So 1 to x minus 2, I write x minus 2 factorial into x minus 1 into x. So this is what we have written here. So x factorial becomes x minus 2 factorial into x minus 1 into x. X and x minus 1 cancels. The moment I write x minus 2 factorial, to make it sense, I have to put x ranges from 2 to infinity. Till then it was 0 to infinity. Now I am left with this term. Denominator x minus 2 tells me lambda power also should be reframed. X becomes x minus 2 plus 2. I want only lambda power x minus 2 and x minus 2 factorial. Take this lambda square separately and out of the sigma. Now this remaining becomes e power lambda by this formula. Already e power minus lambda is there. So e power minus lambda and e power lambda will get cancelled, giving us lambda square plus lambda as e of x square. The next step, we need to substitute in the variance formula. What is variance? E of x square minus e of x the whole square. E of x square is lambda square plus lambda and e of x is lambda. Substituting, lambda square cancels, leaving us only lambda, and we derive, for a Poisson distribution, mean is lambda, variance is also lambda. Theory questions are equally important this year, and such questions will come under 5 marks. Pay attention, learn and be thorough with. Exercise 7.2, question number 6. Mortality rate for a certain disease is 7 in 1000. Find the probability for just 2 deaths on account of this disease in a group of 400. Now it is given 400, such a big number. So we can compare this with a Poisson distribution. For a Poisson distribution, I must identify what is lambda. So lambda tells me n into p. Lambda is average or mean. So in this question, there is no average or mean mentioned. So we will find out using binomial formula, that is n into p. N tells me how many are there. So in a group of 400, so 400 is n. P tells me the probability of the death rate. So it is 7 out of 1000. 7 in 1000 tells me 7 out of 1000, which is nothing but 2.8. The next step, we will substitute in Poisson distribution. So we write x is equal to, what I want is just 2 deaths. So number of deaths. And we know x follows Poisson with parameter lambda. What is the formula for Poisson? e power minus lambda, lambda power x by x factorial. X is from 0, 1, 2 and so on. In this question, I want 2 deaths. So, x is equal to 2. E power minus lambda. What is lambda that we calculate? 2.8. Lambda power x. 2.8 power x value is 2 divided by x factorial is 2 factorial. As I read the problem, 7 in 1000 is the rate tells me P equal to 7 by 1000. Find the probability for just 2 deaths tell me x is equal to 2. In a group of 400 tells me n is equal to 400. As we read the problem, identify n, p, x. Then lambda is n into p and we will write what is x from the last line. And what is Poisson distribution? We must recall this formula. Wherever lambda comes, substitute the value. X is 2. E power minus 2.8 is given in the question itself 0.06. Even if not, you must be able to refer from the table given in the last page of your book. 2.8 the whole square, use calculator, divide by 2 factorial meaning 1 into 2. Simplify and write out the answer. So the answer is 0.2352. Take and write the answer. Probability for just 2 deaths equals 0.2352. Exercise 7.2, question number 7. It is given that 5% of bulbs are defective by a manufacturing company. Use Poisson distribution to find the probability that out of 120 such bulbs, no defective is found. So the word no tells me x is equal to 0. And this 5% tells me it is p, small p. Out of 120 tells me it is n. So let us take and write what all is given. N is 120, p is 5%, that is 5 by 100 and x is equal to 0. Given x follows Poisson with parameter lambda. What is lambda? N into p. 120 into 5 by 100, that is 6. So lambda value is 6. E power minus 6, the value is 0.0025. How to find out e power minus 6 if they don't give the value in the question? This table will be given in the exam. This is exponential function table. In this, you have the column 0, 1, 2, 3, 4, 5, 6 and so on. My question is 6. So, 6 under 0. If it is 6.23, 6 under 23, I must check. 6 under 0.23. If it is 6.35, 6 under 0.35. This point values are given here. This left side decimal, that is 6, 5, like that are given here. My question is e power minus 6. But here I can see only plus value. See 0, 1, 2, 3 like that. So I am under 6. And my question is only 6. So 6.00 I will refer here. So 6.00, my value is 403.42879. This is for e power plus 6. If I want e power minus 6, what should I do? E power minus 6 will be 1 divided by e power plus 6 value. Take your calculator. My answer is 403 if it is plus 6. When I want e power minus 6, 1 divided by 403. So whatever answer I get, I approximate and write it. 0.0025. So either they will give the value in your question or learn to do it from the table given to you. P of x is equal to x. When it is Poisson, the formula is e power minus lambda, lambda power x by x factorial. In this question, I need to find P of x is equal to 0. E power minus lambda value is 6. 6 power x value 0 divided by 0 factorial. We must know e power minus 6, the value is 0.0025. 6 power 0 is 1. 0 factorial is also 1. So my answer is 0.0025. The question is find the probability that there are no defectives. So probability of no defectives is equal to 0.0025 and that is the answer.